It seems that we had some technical difficulties more than that we would have wanted for today. So I am going to try to catch up on this, and naturally, I'm apologizing for this particular mishap. Uh, let me take it from where we left off. So I was mentioning the charts and the numbers on the right side of the screen, and they indicated that there is a real problem, that we are heading for disaster to a certain degree, and although this articles, both for the Forester and Data Core, were written a couple of years ago, or were surveyed a couple of years ago, it does not make it less scary because of that. So the number one reason for disaster still counts as system failure, and that obviously goes into the situation where we patch a system with the wrong patch, or someone issues a command on the data center routers that put the lights off for the entire data center. And because we talk about lights, we're going to talk about power outages as being the second one. And for this particular situation, we need to have some form of redundancy and resiliency. Otherwise, those power supplies will shut down eventually. And natural disaster is another thing, although people tend to think of natural disaster as the main reason for it. It's far less often than a system failure, for example. And last but not least, we're going to talk about cyber attacks as reason for disasters, because if we account for the DDoS attacks that may overwhelm your data center, then we have a lot on our hands. So why is it difficult to have a proper strategy, and why disaster strikes? Well, sometimes it's not our fault. Sometimes we have a lot of workloads constantly getting at it, and it's difficult to keep tabs on those. And sometimes it's just that we do limited or no testing at all for disaster recovery, or we use some out-of-date plans. It's really a complex problem, independent of what exactly is the reason that was for the disaster. Now, the biggest takeaway that we should remember is the fact that no single strategy is going to be sufficient in order to keep the lights on for the business, and you really need all of these elements. We have the high availability, which encompasses systems redundancy in case of foreseeable failures. So think of two web servers that are load balanced and ingesting the incoming request. If one goes down, the other one is still able to process, albeit maybe with performance degradation. But availability doesn't provide for any data protection. So if data from those servers gets corrupted, then you will need to have some form of backup to recover from. The disaster recovery, on the other side, it expands the scope of the failure from a localized resource, or maybe an application or a system, to an entire data center. And to prepare for this, we need to have the IT, recovering application insights and needing regular backups for it. And last but not least, we need normal, old-fashioned backups. And in case of an outage, these solutions will allow you to recover your data in case of accidental deletion, corruption, and later even ransomware. So when we talk about high availability in Azure, we think of resiliency, and in Azure, the basic resiliency starts with a single VM that has 99.9% SLA on premium storage, which is decent. But it still can round up to almost 9 hours yearly if we think about the worst case scenario. And that VM is also a single point of failure, so we can step up our game and put a VM in an availability set. Now, this is a concept in which 2 or more VMs in a data center are grouped and distributed across multiple domains, whereas you can think of a domain as an independently powered rack. And this way, if something goes wrong, there is a guarantee that at least one VM from that set will still be up if something goes wrong. And this raises a bit the SLA going to 99.95. However, if the entire data center goes down, there's nothing useful in it. We cannot make sense of the availability set. So we have the possibility of expanding our availability across the entire region by employing the distribution of the VMs across multiple data centers from that region, which raises the SLA to 99.99. In rough numbers, this is just 1 hour or less than 1 hour per year of potential downtime. And obviously, last, we can grow our availability beyond the regional level by looking into site recovery. And on this site recovery topic, in Azure, there are 2 core services that we want to take advantage for disaster scenarios. The first is called the Azure Site Recovery, or ASR, and the other is called Azure Backup. Now, both of these complement each other in order to give you an end-to-end continuity and disaster recovery solution with a very large scale, or we could say, even unlimited scale. And both of them will make use of the same recovery service, Vault service, which is essentially a storage entity in Azure that houses data, and we can use it to back up various services such as Linux or Windows VMs, Azure SQL databases, and so on. So let's jump in a bit in the browser and note that with ASR, we can replicate Azure VM between Azure regions in just 2 simple steps. Now, of course, when we talk about on-premises, that's also covered too. So we can do site recovery for VMware and Hyper-V machines, and ASR will coordinate the VM and the physical server failover from the primary site to Azure, and can fail back to the primary when everything goes back to normal. There is a third option also. If you want to leverage an additional physical secondary data center to Hyper-V failover. However, please be aware that this is going to be retired in 2023. So it's advisable to use it just for short span projects and not really long-term planning for your disaster strategy. And setting these options, these replication options, is very easy. It's a wizard, it's a guided step, it's a painless process. We need to select the virtual machines that we want to protect, speaking of an Azure to Azure scenario, and then we need to set up the replication settings. And maybe the most important part here is the replication policy, which by default has a 24-hour recovery point retention, meaning that by default, site recovery will keep recovery points for 24 hours. But of course, you can configure this to be a number between 1 and 72 hours and account for that. By default, site recovery also takes an app consistent snapshot every 4 hours, and that's also a configurable value. It's between 1 and 12 hours. Now, an app consistent snapshot contains all the information in a crash consistent snapshot, which the crash consistent snapshot will contain everything that's on the disk on the moment of the snapshot. But the app consistent one will contain whatever is on the disk plus all the data in memory and transactions in progress. And under the hood, app consistent snapshots will use volume shadow service and will make use of a method that does not change Microsoft SQL's transaction log backup time, for example, or SQL sequence number, and also is informing every app on the respective machine that it needs to flush the memory to disk when snapshot is being taken. Now, when we talk about multi-VM consistency, all the machines in a replication group will have a shared crash consistent and app consistent recovery points when they will be failed over. But that comes with penalty, because enabling multi-VM consistency can impact workload performance because it's a rather CPU intensive operation and should be really, really used if you really, really need it. If, for example, we have a two-tier web application but multiple servers, let's say 2 web fronts, 2 SQL servers, you don't need to put everything in a replication group. You just need to put the specific workloads, either the SQL virtual machines or the 2 web servers. And you also need to consider that machines in the replication group communicate with each other over specific port numbers, so you kind of need to account for this requirement both for the Windows and the Linux workloads. All right, cool. So let's see what does happen under the hood. How does ASR work in this Azure to Azure scenario for replication? So we have this graphical infrastructure view representation that we see here. And when we protect a VM with ASR, ASR will install an extension onto that VM, and then the initial replication of the VM disk will happen. This is where we copy the entire disk as initial cutoff from one region to another. And once the initial replication is complete, the ASR extension on the VM keeps tracking any changes happening to the disks and transfers those changes to a buffer storage or cache storage in the same region as the VM. And ASR will do replication further from storage account to the secondary region, and also will be accountable for creating various recovery points to be used in a failover scenario. Now, the way ASR is keeping tabs on the changes on the disk is through a filter driver, which sits at the heart of the OS and directly interacts with the kernel. So in the situation when we want to protect Linux-based VMs especially, the kernel support for ASR is very important. There's a supportability metrics documented that you can check it out depending on your Linux distro. But luckily, the cadence of the Linux kernel support has decreased drastically in the last period, and it's currently sitting at around 1 month, give or take, a short period. And at this point, we need to keep in mind in this entire picture that we are only replicating the disks. No VMs associated with those disks exist in the other region. So that's a plus for us because we don't pay for the compute costs. And because of this particular way of doing things, we also benefit from great RPO. As you can see here, we got like 2 minutes. Well, maybe if I do a refresh, it will change slightly. It's 5 minutes. So why is RPO important? Well, whatever caused that whatever caused that disaster will have a number of consequences. And for example, you might not be able to communicate with your partners and customers, to complete workflows, handle all sorts of transactions, and so on. And a study from DataCore in 2018 showed that only 2% of the surveyed companies recovered from a downtime incident in 1 hour or less, which is kind of worrisome and underlines the need of proper disaster recovery and business continuity plan in place, because you and only you will know what those disaster occurrences and what effect they could have on your business reputation. So you may say here, okay, we got everything, we protected the VM or multiple VMs and everything is healthy, we got no issues and everything. So you could say that you are prepared for the next disaster. Well, it's not quite so, I'm afraid. And this is because, I am sure that you are aware of, it is highly advisable to conduct periodic disaster recovery drills and see if everything works as expected. So towards this, we can use the test failover scenario in which we need to select the latest recovery point, being it a crash consistent or app consistent recovery point. We can also select one older one from the 24 hours maybe. And we need to also select the virtual network where our virtual machine and supporting infrastructure, and by supporting infrastructure, I mean network security groups, I mean the public IPs, I mean virtual networks, NICs, and so on, are going to be spawned. So once we select this option and we click OK, then we are off to recovery. And at this point, all the supporting infrastructure in the VM is going to be created in a matter of minutes, no more than it takes to create those resources normally through the default Azure mechanisms. But this is just a simple VM, and we know that most of the businesses workloads out there are going to be multi-tiered and may require additional specific steps in order to be executed at predetermined times and predetermined order, as opposed to just booting up a new VM. And at this point, a recovery plan comes in very handy. This recovery plan that we have in Azure is nothing different from a recovery plan book that you already have from your on-premise disaster implementation, indicating the steps that we need to take, the order of steps, and so on. By default, in a real failover scenario, ASR will shut down the VMs in the source site and will create new ones in the destination region. But if we look here, we got from the name, you can hint, but we have here a mini SharePoint farm. So it doesn't have anything about the web front. It has just a SQL database server and an Active Directory where we need to authenticate. So it makes no sense that either the SQL Server or the SharePoint web front will start before the Active Directory, because we won't have anywhere to authenticate against. Equally, it makes no sense to start the web front before the SQL, because the users will get 404s. So what we can do here is to distribute the VMs over various groups and corresponding order that we may have. And once this is done, we can also add something called the pre and post actions. And these are represented by running specific scripts during failover. And these scripts will deal with a number of things coming from or ranging from setting up configuration on the new machine, or giving it a new public IP, setting up the certificates, and so on. And all the scripts are going to be hosted in an automation account from your environment, and we will make perfect use of this. But if the scripting is not an option for you, we can also insert manual actions, manual steps, instructions that need to be executing during the failover scenario by the respective personnel. And If we do this, if we distribute whatever servers we have accordingly, if we do pre and post actions, then we take great advantage of orchestration steps for the failover and recovery of multi-tier applications. All right, so moving on to backup now. You can use it to ensure that the critical data gets backed up, irrespective if it is or if it lives on premises or in cloud. So if we talk about on premises, then we have a wide range of options, and you can choose, a normal general backup of your Hyper-V or VM machines from a data center, or you can even choose to do a system state of your physical machine, and so on. Application level wise, we can back up entire SharePoint farms and Exchange ecosystems. And the way that we do it is by preparing a backup infrastructure in our data center, which is coming in the form of an Azure backup server. And from there, you can set up and orchestrate the backups to match your specific RPO needs. There is nothing you can do in the portal for it. Now, if we are talking, on the other hand, about Azure, what we can back up is, again, a good range of choices. We can have virtual machine and even SAP in an Azure VM. And we all know that SAP is a very, very resource-intensive ecosystem. So if you have the virtual machine, you don't need anything else in order to orchestrate this backup. And we will mainly look, or we can make, the greatest sense from a retention policy. And the default one is fine, but it's just daily. So we need to prepare and plan for retention policies that are in sync with our actual needs per se. And the only other thing that we need to do is to simply add the machine that we want to back up, and off we go. It's that simple. Enable backup. We can do this enable backup if we also go onto a virtual machine directly, and we have a backup option in the blade there, and it will just do the same thing. Similar for ASR, we can start the disaster recovery straight from that blade. We don't need to necessarily go in here. Right. So what happens under the hood again when we talk about backup? So if we look here on this slide, starting on left, the Azure Backup Service will initiate a backup job at a scheduled time that we define by the policy, and trigger the backup extension to take this snapshot. And the backup extension will coordinate with the in-guest volume shadow service to achieve consistency. Yeah? And afterwards, we invoke the blob snapshot API of the Azure Storage Service, because every disk for VM stands in an Azure storage. This is being done because we want to get a consistent snapshot of the disks of the virtual machine without having to shut it down per se, after all. So after the snapshot is taken, the data is going to be transferred by the Azure Backup Service to the backup vault. And also at this point, the service will take care of identifying and transferring only the blocks that have changed from the last backup, thus making the backup very, very storage efficient, because we don't do entire snapshots. So when the data is transferred, it's completed, the snapshot is removed and the recovery point is created from this delta. Yeah? And this recovery point is going to be our entry point for setting up, or more precisely, restoring things back from the portal. So if we ever find ourselves in a situation when we want to restore the VM to an earlier point, we could just simply select a restore point from here and proceed with the options that we have, either create a new VM from that restore point or replace an existing one. But also we have the possibility, and we can take advantage of a file recovery, which essentially mounts for us the disk that we selected from the recovery point. And afterwards, we can interact with these contents like any other drive, where we can, browse the content of that particular disk, retrieve what we want to retrieve from that disk, and then just unmount it and let it go. So this is a very, very cool way of just getting back parts of our information if we really want to retrieve maybe a configuration file that got corrupted for a web application or something like that. Right. So if we talk about security and storage security, to be more precise, the data that we transfer during this process is going to be encrypted in transit and is going to be encrypted at rest. And you as a customer can choose to hold those encryption keys. When you back up Azure VMs to backup, then the VMs are encrypted at rest, or the disks of VMs are encrypted at rest with storage service encryption. And this is using either the platform managed keys from Azure, or you can bring your own keys, as I said. And in that situation, you can put those keys inside a key vault, and you will make the best benefit of it. And on top of that, you can also leverage naturally the Azure Disk Encryption functionality, which relies on BitLocker for Windows-based VMs and on TrueCrypt for Linux VMs. And in both situations, Azure will be able to back those VMs too. Now, we got the data in Azure. So when it comes to the security, once the data is there, then we would also need to consider that we can take advantage of additional protection. So one of these advantages comes in the form of multi-factor authentication that we can set up for this vault. And this is a great option because we know that most ransomware attacks will typically attempt to gain control or to alter in some way the backup process by deleting the previous data backups, because otherwise there would be no point in asking for ransom. And to mitigate this threat, when you set up the backup vault, you can configure the recovery services for MFA like here. And what this will do is ensure that the security pin is going to be generated and used to perform critical operations like removing a recovery point, for example. And on top of that, we can also make use of a soft delete option that is a great option for the situation in which a recovery point was deleted accidentally or maybe maliciously by a disgruntling administrator. And this is independent if the MFA was used or not. Now, if we move on to the monitoring part, as you shift to manage failover and data backup in Azure, you also benefit from a lot of built-in monitoring tools for this. And in ASR, the tooling will help you to continuously oversee your BC objectives, because we can see here number of replicated items, number of failover test success, and so on in a single pane of glass with instant visibility. For example, as you can see here, if we attach a new disk to a VM that is already protected by ASR, we are automatically notified regarding the possibility of including the protection for this new disk, and we can either choose to do so or ignore the warning altogether if we really want. And if we talk about monitoring at scale, it's worth mentioning that site recovery events is a great option here. We can generate also email notifications for this, and this also applies for backup alerts, and again, configure the notifications that we can receive per alert or per hour, just to make sure that we are, sitting ahead of the problems, and we can take some proactive measures before an additional problem becomes more and more grave. And if we really, really want to aggregate all this monitoring in a better way, instead of going to the portal and checking things out and so on, we can always push the related logs to Log Analytics workspace. And from here, we can query on specific arguments, we can surface graphical dashboards, we can generate alerts, or export to Power BI in order to have that nice holistic view of your disaster state, in dashboards, and we can use those dashboards in a number of situations. All right, perfect. So now, obviously, before you set up these services, either ASR or backup, getting the most effective use of Azure to handle this takes some planning. For backup, for Azure backup, that is, data is going to be kept default for 30 days. So you really need to work on defining a proper retention policy to satisfy the yearly goals or decade goals that you may have in this situation. For ASR, on the other hand, when we talk about on-site data centers, so Hyper-V or VMware resources, you would need to clarify first which VMs to replicate by assessing the impact to your business if specific apps and workflows you run will experience downtime. And to support this entire planning stage, we have Site Recovery Deployment Planner as an option. This is a tool, a command line tool, that will allow you to profile your VMs, to understand various requirements like bandwidth, like storage requirements, and maybe limitations that we may have. All this for successful replication and failover based on your desired RPO that you can define. And this tool is doing this profiling without any performance penalty, since the performance data is collected from the Hyper-V server or the VMware, vSphere server, which hosts the production virtual machines. So you can run this tool without installing any site recovery components, like we showed for the on-premises world before. And at the end of this operation, the deployment planner will also give you a cost for failing over to Azure. And since we're talking about cost, on a side note, since nobody would really want to pay for evaluating a product, if I may say so, the first 30 days of using ASR are free, after which you are billed mainly for protected number of instances, though obviously other factors will add up some costs, such as bandwidth consumption, for example. All right. So if we think about disaster recovery solutions, we know that they are very, very complex. And planning and executing for this strategy is something that takes time. However, more and more of that time is coming from making sure that all the available data from stakeholders and business owners are available. And Azure will natively provide you with the high availability and reliability for your critical workloads. And you can choose to level up your protection and meet all those compliance regulations you may have by using a combination of ASR and Azure Backup. And as you could see during this presentation, most of the rocket science that we are dealing with when we talk about on-premise traditional data center DR is going to be abstracted away and packaged as much as possible as a one-click failover experience. All right, so that's about it from my side. I know that 30 minutes is, far from being sufficient for this. And I would kindly invite you to join our Aleph table if you need to learn more or if you want to learn more, and we can engage there additionally. So just a second, let me see if there are any questions coming from the audience. I do not see anything here for the moment, so I will take the time in this situation to thank you for participating and for having patience until we solve the difficulties from earlier from a technical perspective. And I do hope that you will continue to remain with us and enjoy also the presentation of my speaker colleagues on the other fascinating topics. Thank you again, and I hope to see you out there on the lobby. Have a great day.